Hi, I'm Seth Price, and I'm the project manager for Aurora Industries. This week, we're working on our first rover. This rover is one of 4. This week, we are doing the Bhatt rover. We had a few issues with the Bhatt rover, but we'll be addressing that later. Now, I'm going to pass it over to Cole to address some of the informational stuff and the amount of weight that our robot is going to be carrying.
Hi, my name is Cole Hilton, and I'm the informational analyst at Rover Industries. Now we're going to talk about the safety of the rover, especially the traction and load distribution. Now our rover is going to have to carry literally thousands of pounds of weight if we want to steady ice caps and prepare Mars for colonization. So we need to have an equal weight distribution on the rover because ice caps are very slippery. And Martian ice caps are actually CO2 hardened ice. So that means it's going to be extra hard and slippery. And the rover's wheels aren't going to be able to dig into the ice itself that efficiently. So we're going to have specialized wheels, efficient load distribution, and we're just going to have to be genuinely vigilant about how we're going to load weight onto the rover, what wheels we're going to use, and furthermore, how to actually drive the rover on the ice.
I'm Lucas Mueller and I'm a part of the design team. The Bhatt is a new solution to the Bhatt because of the independently rotating wheels. It allows for more precise movements and at the same time will allow for the rover to turn at a better rate. It also has parallel wheels to ensure that we're not making any errors in our movements and that it's not going to off-place the bot even more. Another thing is with the parallel wheels that it basically will allow for different mass distribution onto the bot and also at the same time will allow for us to get into tighter spaces. Another thing that the independently rotating wheels can do is also, in addition to the more precise movements, would also be getting up and going over terrain that is in our way.
Hello, my name is Willem Sturr. I'm the Aurora Industries Safety and Security Manager. And when it comes to the safety of this robot, one of the main concerns that we have is the fact that the robot could possibly fall and slip on the ice. If this scenario were to be the case, we would have to evacuate all workers out of the area immediately. Another thing we would have to do is immediately take apart our robot and fix the necessities in order to get it moving and up again. So in addition to making sure the safety of the robot is secure, another factor we have to consider is security itself. Now, when checking inside the robot, we have to make sure that nobody has tampered with it or made it faulty in any way, shape, or form. Another feature I'd like to mention is the security itself and getting to deal with any people that could deal with it like that. You know, they could tinker with it. They could change things we never wanted them to. So we have to make sure we put in place routine security checks in order to.
Hello, I'm Jacob Hamilton and I'm the media designer for Aurora Industries. So what I'll be talking about is the way we get the 3D modeling, the cameras, and everything on the rover that tells us anything about where it is in the media involved in it. So the rover has 27 cameras that are capable of 3D modeling areas around itself where it can determine whether it can't go somewhere, where it's limited to, such as ice, lack of height where it can't fit in, and also it gives us 3D diagrams of what it's like on Mars so we can see a program at our base safe from all the debris, the weather, the harsh temperatures, and we can observe the exact shape, obstacles, and anything interfering with our robot. And also we can get those images to the public, producing high definition cameras, pictures, videos, and anything to share our progress.
Hello, I'm Justin Malarkin, and I'm the lead coder and design team member for Rover Industries. So we had some issues when we were creating our robot. We were originally going to use the Bhatt, but we found out that because the wheels and the way that they're oriented, we could not have them go at the same time to move in one linear direction. They can move at a diagonal, but they could not move together in tandem. Another issue I found with the program was that loops did not work. So if you had any sort of weight commands, it would skip over the weights and it would just restart back to the top of the code. So when I was building the code that we currently have, I had it move forward and I had it wait and then I had it rotate. But the issue with that was it would just skip the rotation and just keep going forward.